Okay, in this problem we want to decide whether the series from n equals 2 to infinity of 1 over n log n converges or diverges. As always, we start with the divergence test. And we see that the limit as n goes to infinity of the terms is just equal to 0, right? Because both n and log of n are approaching infinity. Okay, so there's no conclusion. Looking at this, though, we see that our terms an is equal to f of n, where f of x is equal to 1 over x log x. And we can integrate this function. So this makes us think that maybe the integral test is a good idea. So let's just calculate this integral just to make sure we see how. So we have 1 over x log x. Okay, we're going to do a u substitution here with u equal natural log of x. Then du is 1 over x dx. And we have the integral of 1 over u du. Okay, because my 1 over x was grouped with dx to become du. And we can integrate this, we get the natural log of the absolute value of u, or the natural log of the absolute value of 1 over x. Okay, this is also equal to negative the natural log of the absolute value of x. Right, because this 1 over x is x to the negative 1. All right, so we've calculated that we can integrate this. Check. All right, so as long as we satisfy our hypotheses, the integral test is going to tell us that the divergence or convergence of this series is going to exactly mirror the divergence or convergence of the improper integral from 2 to infinity of 1 over x log x. Okay, so let's check our hypotheses. So we need to check decreasing, positive, and continuous. All right, we are continuous as long as x is greater than 1, right? So we're continuous for x greater than or equal to 2. We are positive, right? And we're definitely decreasing because we're the reciprocal of product of increasing functions. So increasing functions multiply together to be increasing. When we take the reciprocal, we get something decreasing. We could also take the derivative, and I encourage you to do that if you're not sure why this is a decreasing function. Okay, so that means that we satisfy the hypotheses of the integral test. So when we work out the integral from 2 to infinity of 1 over x log x, our improper integral is equal to the limit as b goes to infinity of negative log of b minus negative log of 2. This is the limit as b goes to infinity of log 2 minus log b. And we can see here that this diverges. Therefore, by the integral test, the series that we are interested in from n equals 2 to infinity of 1 over n log n also diverges, since its behavior mirrors the divergence and convergence of the improper integral.